So let's start with the next question. So we'll do few more questions with these formulas. Okay. So let's read the next question. A person sitting in the ground floor of a building notices through the window the height of a 1.5 meter. A person sitting in the ground floor of a building notices through the window of height 1.5 meter a ball dropped from the roof of the building which crosses the window in 0.1 second. What is the velocity of the ball when it is at topmost point of the window? So let's understand this question. So let's try to understand this question. This is a building. Okay. This is a building and a person is standing out here. He is holding a ball and this is a window of a building. This is the window of a building. Okay. The height of the window is 1.5 meter. 1.5 meter. Okay. Now the ball is dropped. Now this ball is dropped. This ball is dropped, and as soon as it reaches here, a person seeing out here, a person looking out here sees the ball drop or cross this 1.5 meter in 0.1 second, or time taken to cross this 1.5 meter, time taken to cross this 1.5 meter is 0.1 second. T is equals to 0.1 second. Find out the velocity when the ball was out here. Find out the velocity when the ball was out here. So you have to find out the velocity of the ball at this position. Okay. So let's start. The ball was dropped. Whenever a ball is dropped or released, the initial velocity is always equals to 0. And the acceleration is always equals to gravitational acceleration is equals to 9.81, or in the question it is given as 10. Okay. Question it is given as 10. Okay. Now let's assume there is some velocity out here called v. Okay, v. So let's apply the formula. S is equals to ut plus half at square. S is equals to ut plus half at square. Okay. Now S out here is nothing but 1.5 meter. 1.5 meter, or the height of the window. U is nothing but U out here, or V out here. This initial velocity is nothing but the V out here, because we have to find out the velocity with which it crossed the window. V, and time is given as 0.1 second plus half. A is nothing but G, because even the acceleration out here is equals to G, or is equals to 10 meter per second square. Okay. So let's write G as 10. Let's write G as 10 into 0.1 square. So when we simplify and solve it, if we simplify and solve it, 1.5 meter is equals to 0.1 V plus 5 into 0.1 square, or 0.1 square. So when we simplify and solve this, what our answer comes out to be is U is equals to 14.5. Or let's simplify it. Let's simplify it. Or 1.5 meter is equals to 0.1 U, or 0.1 V plus 5 into 0.01, because 0.1 square is equals to 0.01. So 5 into 0.01 is 0.05. Okay. So this is our equation. Okay. Or V is equals to 1.5 minus 0.05 is equals to 0.1 V, or by solving this we get v is equals to nearly equals to 14.5 meter per second. So our correct option is option number B. So when the ball is out here, the velocity of the ball is equals to 14.5 meter per second. Okay. So now let's look at the next question. A ball is thrown vertically down with a velocity of 20 meter per second from the top of a tower. It hits the ground with a velocity of 80 meter per second. Find the height of the tower. Find the height of the tower. Now, this problem, the person holding the ball, instead of dropping it, the person holding the ball, instead of dropping it, he throws it down. Okay? The person throws down the ball. So, initial velocity is equals to 20, not 0. Okay? Initial velocity is equals to 20. And initial acceleration is equals to acceleration due to gravity, which is equals to 10 meter per second. Now it is given that before striking the ground, the final velocity is nothing but 80 meter per second. And similarly, acceleration remains constant at 10 meter per second square. Okay? Find out this height of the tower. Find out the height of this tower. So between those three formulas, whenever acceleration is constant, we always have to apply three formulas. V is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2s. So between those three formulas, which one should we apply? Velocity, initial and final velocity is given, and acceleration is given, and we need to find out the height, or s. This height can also be written as distance traveled by the ball. Okay? So we can easily apply the third formula because we don't need time out here. There is no equation of time out here, and we also don't need it to as. Okay? Or what is the final velocity, which is v square? Final velocity is 80 square. Initial velocity is 20 square plus 2 into 10 into s. S is nothing but height of the tower, or the distance travelled by the ball in covering from 80 to 20, changing its velocity from 80 meter per second, so 20 meter per second to 80 meter per second. So 80 square minus 20 square by 2 into 10 or by 20 is equals to s. So 80 square minus 20 square is equals to 80 into 80 plus 20 into 80 minus 20, a square minus b square. So 100 into 60. This can be written as 80 square minus 20 square can be written as 100 minus 100 into 60, because a square minus b square is equals to a plus b into a minus b. So 100, which is equals to a plus b, into 60, which is equals to a minus b, by 20 is equals to s. So if we solve this, we get 300 is equals to s. Therefore, the height of the tower is equals to 300 meters. Okay. So correct option is option number C. Okay. So let's look at the next question. A toy car with charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E due to force QE. Its velocity increases from 0 to 6 meter per second in 1 second duration. At that instant, the direction of the field is reversed. The car continues to move for 2 more seconds under the influence of this field. The average velocity and the average speed of the toy car between 0 to 3 seconds are. Okay. Now here just make a note. Acceleration is always caused by force. Without force there is no acceleration. Okay. We'll learn that thing in detail in Newton's law of motion. But for now just remember that acceleration is always caused by force, by presence of force. Okay, because F is equals to ma. Without force there is no acceleration. Now let's understand the problem. Let's understand the problem. Okay, a particle was out here at time t is equals to 0. Particle was out here at time t is equals to 0. Its initial velocity was equals to 0, and the force, there was some force applied to it in the right hand direction. There was some force applied to it in the right direction. So there was some acceleration. There was some acceleration in this direction, but we don't know the value of acceleration right now. Okay, so it started moving, and at t is equals to 1 second, at t is equals to 1 second, at t is equals to 1 second, the velocity was measured to be v is equals to 6 meter per second. Okay, 6 meter per second. So throughout this journey, a constant acceleration of some value a was acting on this line or on this path. So let's find out the value of acceleration. So we know that v is equals to u plus at. Okay, so the motion, the final velocity is 6, the initial velocity is 0, plus a we don't know, and time taken to travel is 1 second. So from this equation we know that acceleration is equals to 6 meter per second square. So acceleration was equals to 6 meter per second square. Okay, now as soon as the particle reached out here, okay, what they did was they reversed the acceleration. That means they reverse the direction of the force. That means acceleration is now acting in opposite direction. Whenever you reverse the direction of force, the direction of acceleration is always in the direction of total force or net force. Okay, direction of acceleration is always in the direction of net force. Okay, so after coming to this point, they reverse the direction of the force. That means they reverse the acceleration. They reversed the acceleration. Okay, with the same value, the magnitude of that acceleration is same as before. That means a is equals to 6 meter per second, but in the opposite direction. Okay, because same force, the magnitude of the force remains same, but they started applying it in opposite direction. Okay, so from here, suppose this particle was moving with velocity and they applied acceleration in opposite direction. It will move for a little bit. Just imagine a car is moving and you applied braking force. The car will move a little bit forward before stopping. So similarly, it moved a little bit forward before stopping. Okay, before stopping, and then due to this acceleration, it started moving in the backward direction. Okay, I am showing this diagram in 2D. See, but the car actually means started moving in the reverse direction in the same line. Just for the simplification of understanding, I am drawing this line in a separate thing. Okay, the car was actually moving in a straight line. Okay, do not confuse that. Okay, so before stopping, before reversal of the direction, the velocity becomes 0. The velocity becomes 0, and the acceleration is still acting in backward direction. Okay, 6 meter per second square, or acceleration is equals to 6 meter per second square. Okay, this is our problem. Now you need to make an observation. Okay, observation. The direction of the field changes the direction of acceleration, but the magnitude of acceleration stays the same. Okay, as I said earlier, the direction of the field changes the direction of acceleration, changes the direction of acceleration but the magnitude of acceleration stays the same. But the magnitude of acceleration stays the same. Okay, now let's apply our one of the three formulas. S is equals to ut plus half at. S is equals to ut plus half at square. Okay, S is nothing but displacement is equals to final position minus initial position. It has nothing to do with the route taken. Okay, so total distance or total displacement or S total is equals to, now see this diagram out here, S total is equals to displacement from here to here or from 0 to 1 second and plus from 1 to 3 seconds, from t is equals to 1 to t is equals to 3 seconds, because out here the time taken to cover this much distance or time taken to go forward and return back is equals to 0 to 3 seconds, means the entire journey was completed in 3 seconds. Okay, the entire journey from the starting of the clock was completed in 3 seconds. Okay, so total displacement is equals to displacement from 0 to 1 plus displacement from 1 to 3. Okay, so total displacement is equals to displacement from 0 to 1 second plus displacement from 1 to 3 seconds. Okay, or total displacement is equals to, let's substitute, total is equals to, what is S0 to 1? S0 to 1 is nothing but ut plus, let's write it little upwards so we can substitute it better, or S total is equals to ut plus half at square. Okay, now let's look 0 to 1. U was equals to 0, t was equals to 1 second and a was equals to 6. So u was equals to 0, t was equals to 1 and a was equals to 6. Okay, plus S 1 to 3 seconds. For here also we apply the same formula. S is equals to ut. S is equals to ut plus half at square. From S is equals to 1 to S is equals to 3. So now let's look at this. S is equals to 1 to S is equals to, sorry, from t is equals to 1 to t is equals to 3. Initial velocity from t is equals to 1 to t is equals to 3 is equals to 6. Initial velocity is equals to 6. We are starting it from here. And the acceleration is also 6 but in the opposite direction. So initial is from 6. Okay. And the acceleration is also 6 in the opposite direction. So we take minus 6. Why? So whenever the velocity and the acceleration is in the opposite direction, okay, it's better to assume a coordinate system, but I'll show you a little bit later how that is done. But for now, just remember, whenever velocity and acceleration is in the opposite direction, okay, both are in the opposite direction, you take either any one of the value to be negative. Okay, both cannot be positive together and both cannot be negative together. Okay, this can be simplified by assuming a coordinate system, but that I'll teach you a little bit later. Okay, for now, whenever velocity and acceleration are in opposite direction, just take the acceleration in negative. Okay, just take the acceleration in negative, and time is equals to t is equals to 1 to t is equals to 3, or 3 minus 1, time is equals to 2 seconds, because 1 to 3 seconds is time is equals to t is equals to 3 minus t is equals to 1, or is equals to 2 seconds. Okay, now when we substitute this, or S total is equals to 0 into 1, 0 into 1 is 0, half into 6 into 1 square is equals to half into 6 is equals to 3, or 3 meter, plus, now let's look at this, ut means 6 into t is nothing but 12 minus, this minus goes out here, so 12 minus, let's write it in parts, so 12 minus half into 6 into 2 square, which is 4, so half into 6 into 4, that means 12 minus half into 6 into 4 is 12, or this comes out to be 0, okay, or is equals to 3 meters. That means what did this equation tell us? This equation told us that from 0 to 1 meter it moves 3 meter, from 0 to 1 second it moves 3 meter, and from t is equals to 1 to t is equals to 3 second it did not change its position, it moved forward and returned back, but its initial position and the final position of the particles are same. See, the displacement of second one, 12 minus 12 becomes 0. That means the initial position and the final position at t is equals to 1 to t is equals to 3 is same. That means the particle went back forward and returned back to the same position as t is equals to 3. Okay, now let's go to the next page. Okay, so t is equals to 0 to 1 is equals to 3 meter. Okay, and the particle went forward and returned back. For now we just know that from t is equals to 1 to t is equals to 3 second there was no actual displacement. Okay, so average velocity, and velocity out here is equals to 0, because before returning the velocity would be 0. So therefore average velocity is nothing but total displacement by total time, total displacement by total time, which is equals to, or average is equals to, velocity average is equals to total displacement was what? Initial position minus, final position, this final position minus initial position, or final position is at 3 meter per second. Okay, or is equals to 3 by total time taken was 1 2 3. Okay, time taken was 3 seconds, or average velocity was 1 meter per second. Okay, the average velocity was 1 meter per second. So from option number C and option number D are automatically eliminated. Okay, now for average speed, average speed is nothing but the length of the entire path divided by total time. That means this path plus this path plus this path. Okay, or total distance by total time, So how to find out this distance from t is equals to 1, where velocity was equals to 6 meter per second, to velocity is equals to 0 meter per second? How to find out this much distance? How to find out this much distance? So we know that v square is equals to u square plus 2as. So let's use a formula. Okay, v square is equals to u square plus 2as. Okay, and this s, the s out here is nothing but the time taken to change its velocity from 6 meter per second to 0 meter per second. So this much distance will be covered when 6 meter per second changes to 0 meter per second under the influence of acceleration 6 meter per second square acting in backward direction. Okay, so final velocity is nothing but 0 square, initial velocity is nothing but 6 meter per second square. How 6? See, we already obtained at t is equals to 1, velocity was equals to 6. Okay, plus into acceleration was 6 meter per second but in the opposite direction, so we take as minus 6. Okay, for now just remember, whenever acceleration and velocity are in the opposite direction, take acceleration to be negative. Okay, into s is the displacement, or 0 square is 0, 6 square become 36, so minus 36 is equals to minus 12s, or 3 is equals to s. Okay, so this distance became 3 meters. That means the distance traveled by the particle to reduce its velocity from 6 meter per second to 0 meter per second is 6 meter. So if this distance is 6 meter, if this distance is 3 meters, then in the backward position this distance will also be 3 meters, because the final and initial position were same in the t is equals to 1 to t is equals to 3 seconds. So this distance is also equals to 3 meter. Now let's look at average speed. Average speed is equals to total distance, which is equals to 3 plus 3 plus 3, which is equals to 9, divided by total time. Total time is nothing but 3 seconds, is equals to 3 meter per second. So our correct option is option number B. Okay. Now I'll teach you the trick of coordinate system. Coordinate system means whenever, right now most of the cases your acceleration and velocity are acting in the same direction, but this might not always be the case. Okay, so let's devise a trick. Okay, here when acceleration and velocity are in the opposite direction, assume a coordinate system. That means, let's write it, then I'll explain it to you. When acceleration and velocity are in the opposite direction, assume a coordinate system. Assume a coordinate system. Okay, which means what? Which means, suppose I am throwing a ball. Suppose this is ground. I am throwing a ball with upward velocity v. The acceleration is in the downward direction with a is equals to g. So you can either take this coordinate system that upward is positive and downward is negative, or vice versa. Similarly, you can either take right to be positive and left to be negative. Okay, and or you can take upward to be negative and downward to be positive, right to be negative, and left to be positive. But this is more recommended. This top portion is more recommended. Means usually take it like this. Okay. So after this, what does it represent? This coordinate system represent nothing but any vector. Any vector means displacement, velocity or acceleration that are in the upward direction will always be considered positive in the formula, and any vector, that means either displacement, velocity or acceleration that are in the downward direction, will be considered negative in those three formulas. Okay, those three formulas are v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2s. So any vector, either displacement or velocity or acceleration that points towards upward direction is positive. Okay, and any vector that is pointing in the downward direction will be negative. So displacement, acceleration and velocity are all vector quantities. So what are vector, what are scalar? I'll teach you something preliminary about vectors, but just remember displacement, vector and acceleration, both these three are vector quantities, but time is a scalar quantity. Okay, time can never be negative. Okay, all are vector quantities. And the positive and negative values on this vector determines the direction, and the positive and negative values on these vectors determines the direction. That means what? That means v is something, velocity was positive v, acceleration was negative g or minus g. Okay, that means if we plug in positive v and minus g in the equation, the displacement would come. If it is come as positive, that means the displacement moved upwards or displacement is in this direction, and if it is negative, that means the displacement is in downward direction. Okay, so you put the values and plug it in the equation. Whatever the values comes out, either positive or negative, that determines the direction. Okay, now we have to solve this problem. We solve this problem using graphical method. So let's take this problem again. Now I have to solve the same problem. I'm solving the same problem but using graphical method. Okay, let's take velocity time graph. From 0 to t is equals to 1, the velocity increased. From 0 to t is equals to 1, the velocity increased. Okay, and the velocity was 6 meter per second. 6 meter per second. Okay. Now from t is equals to 1 to t is equals to 3 second. It moved forward. It moved forward and returned back to its initial position, Minus means nothing but negative velocity. That means after v is equals to 0, the velocity also reverses direction. After v is equals to 0, okay, after this position, after v is equals to 0, the velocity also reverses direction. That's why this is negative v. Okay, so let's draw it out here so you can understand it a little bit better. So it started out here, v is equals to 6 or t is equals to 1, then it went up till here, then it returned. This return area is nothing but this much area, okay, and t is equals to 3, t is equals to 3, t is equals to 0. Now we know that area under the VT curve gives us displacement. So this total area minus this total area is equals to displacement, or let this total area be A and this total area be B. Okay, so therefore average velocity is equals to area of A, or area of A minus area of B minus area of B by total time taken, or t is equals to 3 minus t is equals to 0, or t is equals to 3 minus t is equals to 0. And average speed is equals to area of A plus area of B, which is equals to total distance. Area of A is what? This area is A of A is what? Displacement from x is equals to 0 to x is equals to some this point, okay, divided by total time taken, 3 minus 0. Okay? This is the total time taken. Let's draw it properly. So this gives us a very important mathematical observation, okay, very important mathematical formula. Just make a note. Whenever the average value, you need to find out the average value in a graph or in an equation. Suppose there is an equation and a graph is given. You need to find out the average value, and this is y, this is x. Okay? From x is equals to 0 to x is equals to say something value of a. Okay, so if you need to find out the average, average value of y throughout this entire length, s equals to 0 to x equals to a, you need to find out the average values of this curve, or what is the average value of this y is equals to fx. So the best way to find it, average value of y is equals to area of curve, area under the curve. That means area under the curve by range. Range means x equals to a minus x equals to 0 by range. That means the range from x equals to a to x equals to 0, x equals to a to x equals to 0. Mathematically this can be written as, so mathematically this can be written as average value of y. So y average, or average value of y, is equals to integral or area under this curve from x equals to 0 to x equals to a. Area under this curve is integration of y dx from x equals to 0 to x equals to a, divided by range. Range is nothing but dx, x equals to 0 to x equals to a. This is how we write this mathematically. Okay, this is how we write this mathematically. So let's do a next question. A stone falls freely under gravity. It covers the distance h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds respectively. The relation between h1, h2 and h3 is. This is a bit theoretical concept, but I'll be applying it with using the same 3 formulas. Just remember, in this answer I'll be making a conclusion that you have to remember for better competitive edge, or getting a. So a person standing on the rooftop dropped a ball. Dropped means u is equals to 0 and a is equals to g is equals to 10 meter per second. Okay. The height h1 was during the first 5 seconds, or t is equals to 5. For the next 5 seconds, okay, next 5 seconds means from t is equals to 5 to t is equals to say some value, the 5 seconds has elapsed. That means from t is equals to 0 to t is equals to 10. Okay, so from t is equals to 0, 10 seconds has elapsed. So this height h2, or let's write h2. Now after this 10 second we add 5 more seconds. That means t is equals to 0 to t is equals to 15, or this whole distance is h3. So let's not write this as h, let's write this as s, because in the question also the variable is given as h. You will get confused. So s1, s2, s3. So let this be s1, s2 and s3. So using the formulas, s is equals to ut plus half at square. Using the formula, s is equals to ut plus half at square. S is equals to ut plus half at square. S1 is equals to ut. U is nothing but 0. So 0 into t is 0 plus half. A is nothing but 10. Why is it positive? Because our displacement, we considered the downward vector to be positive. We assumed downward to be positive and upward to be negative. So before solving any problem, when you are new in kinematics, before solving any problem, always make these grids. Okay, always make these grids. Okay, so half into 10 into t square. T is nothing but 5 seconds, or 5 square, or s1 is equals to half into 10, which is 5 into 5 square is 25, or is equals to 125 meter. Okay. Similarly, s2 is nothing but from t is equals to 0 to t is equals to 10 seconds, or initial velocity is equals to 0 plus half 10 into 10 square, or s2 is equals to 5 into 100. 5 into 100 is equals to 500. And s3 is equals to 0 plus half into 10 into 15 square, or s3 is equals to 5 into 225. 15 square is 15 into 15 is 225, or is equals to 1125 meters. So we found out the value of s3, which is equals to 1125, s2 is equals to 500, and s1 is equals to 125. So let's take a next page. let's take a next page. Our S1 is equals to 125 meter. Okay. S2 is nothing but the total distance from the rooftop of the building is equals to 500 meter. See, S2 is equals to 500 meter. And S3 is nothing but the total distance from the roof of the building to the bottom of the, from t is equals to 0 to t is equals to 15 second. T is equals to 0, t is equals to 5, t is equals to 10, t is equals to 15. But S3 is equals to, S3 came out to be 1125, or S3 is equals to 1125 meter. Now in the question they have given us this distance, or S1 is equals to H1. In the question they have given us this distance to be H1, this distance to be H2, and this much distance to be H3. Okay, they have classified the distance like this. So we know that H1 is nothing but S1, which is equals to 125. H2 is nothing but S2 minus S1, or 500 minus 125, or is equals to 375. And H3 is nothing but S3 minus S2, or 1125 minus 500, 1125 minus 500, which is equals to 625 meters, which is equals to 625 meters. Okay. S3 is equals to S3 minus S2, which is equals to 1125 minus 500, which is equals to 625. Now let's check our option. Option they have given in the ratio of H1 is to H2 is to S3. So we can clearly see that 125 into 3 is 375, and 125 into 5 is 625. H1 is equals to 125, H2 is equals to 125 into 3, or H3 is equals to 125 into 5. We can also write this as H1 is equals to H1, H2 is equals to H1 into 3, and H3 is equals to H1 into 5. Okay, so let's check our option. H1 is equals to 2H2 is equals to 3H3. This option is entirely wrong. H2 is equals to 3H1. See, H2 is equals to 3H1, and H3 is equals to 5H1. So option number B is correct. Option number B is correct. Okay. Now this type of lengthy calculation are usually means if you have practiced enough of this, so there is a trick to learn. There is a trick to learn from this question. Okay. Suppose under constant acceleration, there is constant acceleration and initial velocity is 0. After constant acceleration, the second condition is initial velocity should be 0. The distance covered in first t second is to second t second. That means if this is 5, this should also be 5. If this is 10, this should also be 10. To third t second is equals to, or suppose this one is H1, first 5 seconds or first 10 seconds. Okay, H2 is similar time period or distance covered in similar time. So h1 is to h2 is to h3, h1 is to h2 is to h3 is to, this might be h4, h5, h6. Okay, they progress in the sequence of odd numbers, 1 is to 3 is to 5 is to 7. Okay, they progress in the sequence of odd numbers. That means h2 automatically becomes 3h1 and h3 automatically becomes 5h1. If there was h4, h4 was 7h1. Okay, and this formula even applies in horizontal direction, this formula even applies in horizontal direction if the acceleration is constant. If the acceleration is constant and initial velocity is 0, and initial velocity is equals to 0. Note that this formula would fail if initial velocity is not equals to 0. If a person, instead of dropping it, throws it, do not apply this formula or do not apply this trickery. Okay, do not apply this trickery when the person or when the initial velocity is not equals to 0. This formula only works when the initial velocity is equals to 0. Okay, so let's read the next question. A boy standing at the top of a tower of height 20 meters drops a stone. Drops a stone means initial velocity of the stone is 0. Assuming g is equals to 10 meter per second square, the velocity at which it hits the ground. This is directly formula based. This is simple enough formula based question. The person standing on top of the tower drops a stone. That means initial velocity is equals to 0 and acceleration is equals to 10 meter per second square. 10 meter per second square. Okay. Now the height of the tower is 20 meters. Height of the tower is 20 meters. Find the velocity of the ball when it reached 20 meters down. So similarly we apply the simple formula of v square is equals to u square plus 2as. Okay, or final velocity we don't know. Initial velocity was 0 plus 2 into acceleration is nothing but 10 into s is 20. Okay, s is nothing but 20. Or v square is equals to 0 square is nothing but 0 into 2 into 10 into 20 is nothing but 400. 2 into 10 is 20 into 20 becomes 400 or is equals to 400. So v square is equals to 400 or v is equals to square root of 400, which is equals to 20 meter per second. So final velocity is correct option number A, or final velocity is 20 meter per second. So let's proceed on to the next question. Okay, let's proceed on to the next question. A ball is dropped from a high rise platform at t is equals to 0. Starting from rest, after 6 seconds another ball is thrown downward from the same platform with speed v. The two balls meet at t is equals to 18. What is the value of t? Okay, so let's see what the problem is talking to us. The problem says there is a height, okay, and the person dropped the ball with initial velocity is equals to 0 and acceleration is equals to g. Okay, after 6 seconds, after 6 seconds from the same building, the same person, now instead of dropping the ball, he threw the ball down. He threw the ball down. That means there must be some initial velocity v, and the acceleration is same because the force of gravity acting on this particle is same, or acceleration is equals to g. Okay. At 18 seconds, now the question is given us at 18 seconds, the displacement of both the ball will be same. That means the ball started moving from here till here, and after 6 seconds he threw the ball with some velocity, and after from 0 to 18 seconds the ball reached the same height. Okay, after 18 seconds. After 18 seconds the displacement of both the ball will be same. After 18 seconds the displacement of both the ball will be same. That means you have to apply a simple formula. S is equals to ut plus half at square. This is the formula that we have to apply. So this formula when applied for first ball, S is equals to ut, u is nothing but 0 into t is 18, but 0 into 18 is 18, plus half. Why half? Because I consider this direction to be positive and this direction to be negative. Okay, and any vector pointing downwards is positive, any vector pointing upwards is negative. Half into 10 into 18 square. Okay, for first ball. For second ball, the second ball was released after 6 seconds. So but with some initial velocity v. So v or u, initial velocity was v. Okay, v into t. T is nothing but 18 minus 6. That means after 18 seconds the ball will meet, and the ball was released 6 seconds after the first ball. So time taken for this journey is 18 minus 6 plus half into 10 into 18 minus 6 square into 18 minus 6 square. Okay, this is the value of second ball. Okay. Now let's solve this. When we solve this, now displacement of the first ball and the second ball and the second ball, let me write it properly, and the second ball is the same. Therefore S1 is equals to S2, or 0 into 18 plus half into 10 into 18 square is equals to 12 into v, or 18 minus 6 is 12v, or ut plus half a is nothing but 10 into t is 12 square, or 18 minus 6 square. Okay, or this gives us 1620. 18 square into 5 is 1620 into 12v sorry. Okay, let's calculate it. Okay, instead of writing, let's calculate it. I think 94745. let's use a calculator. So 18 square is something around 324 into 5 or is equals to 1620. Yes, I am correct. Is equals to 12v plus 12 square is 144 into 5. So 144 into 5 or is equals to 720. Okay, or 1620 minus 720. 1620 minus 720 is nothing but 900. 900 divided by 12 is around 75. 900. So 900 is equals to 12v divided by 12 is around 75, or v is equals to 75 meter per second is equals to v. So let's check the option. Option is 74, 55, 40 and 60. So our correct option is option number A. So why this disparity between 74 and 75? See, in kinematics the value of g is always 9.8. Okay, and this disparity comes due to that. Okay, this disparity comes due to the value of g. Somewhere in the solution they take out to be 9.8 and somewhere in the solution they took to be 10. That's why this kind of disparity occurs. Okay. Let's start the next question. A particle starts its motion from rest under the action of a constant force. The distance covered in first 10 seconds is s1 and the covered in first 20 seconds is s2. Then that means you have to apply the simple formula. S is equals to ut plus half at square. This is the simple formula that you have to apply. S1 or first 10 seconds, a particle starts its motion from rest. That means initial velocity is equals to 0 or 0 plus half on the action of a constant force. That means there is some acceleration. The first 10 seconds is 10 square or S1 is equals to 100 divided by 2 is equals to 50A. 50 50A. Similarly for S2 or distance covered in first 20 seconds, S2 is equals to 0, initial velocity was equals to 0 plus half A into 20 square, or 20 square is nothing but 400 is equals to half into 400 divided by 2 is 200A is 200. Why am I writing such wrong things? 200A. Now the question is asking find the equivalence of S2 and S1. Find the equivalence of S2 and S1. So you can clearly see S2 is equals to S1 into 4. So we simply divide. Therefore S2 by S1 is equals to 200A by 50A, which is equals to 4, or S2 by S1 is equals to 4, or S2 is equals to 4 S1, or S2 is equals to 4 S1. So our correct option is option number C. Okay. Now let's move on to the next question. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance of 135 meter in t seconds. The value of t is. So this is a simple formula of v square is equals to u square plus 2as. V square is equals to u square plus 2as. The final velocity was given as 20 meter per second. The initial velocity is given as 10 meter per second. The displacement is given as 135. You have to find out acceleration. After acceleration, you can apply the formula v is equals to u plus at, then find out the time. Okay. So 20 square is 400, 10 square is 100 plus 2 into a into 135. So 2 into 135 is 270. 135 into 2 is 270 or 270 into a. Okay. So this becomes 300 divided by 270 is equals to a. Or when this is simplified, this becomes 10 or 3 tens are 30 by 3 nines are 27 is equals to a. Now we have to apply one more formula. V is equals to u plus at. The final velocity is 20. The initial velocity is 10. Acceleration we found out to be 10 by 9. And the question asks us for our time t. The question is asking for time t. Whenever the acceleration is constant, you can always apply these three formulas. V is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. And Sn, that one is a special case moving in fourth seconds or fifth second. That Sn was equals to half a 2n minus 1 plus u. That is a special case of s is equals to ut plus half at square. Okay. Or if we solve this, 20 is equals to 10 plus 10 by 9 into t, or t is equals to 9 second, or 9 is equals to t. Our correct option is option number T. Okay. So let's proceed to the next question. The distance traveled by a particle starting from rest moving with acceleration 4 by 3 meter per second square in the third second is. So in the third second, that means that the distance traveled from t is equals to 3 to t is equals to t is equals to 2 to t is equals to 3. The third second means the distance traveled from time is equals to 2 second to time is equals to 3 second. You start a stopwatch as 0. So from time is equals to 2 second to time is equals to 3 second, the amount of distance it moved is equals to given by distance traveled in third second. So distance traveled in third second, we directly apply the formula, which is a special case is of s is equals to ut plus half at square. S is equals to half into acceleration into 2n minus 1. The third second is n is nothing but the nth second plus u plus initial velocity. So initial velocity is equals to 0 because the body started from rest. So or Sn is equals to half. Acceleration is given by 4 by 3 and the time is given by third second, or 3 into 2. 3 into 2 is 6 minus 1 plus u is nothing but 0. Or distance traveled in third second, which is equals to time is equals to 2 to time is equals to 3 second, or 2 by 3 into 5. 2 by 3 into 5, which is equals to 10 by 3 meters. The correct option is option number C. Okay. S is equals to ut plus half at square. The S is always calculated from t is equals to 0 and S is equals to 0. Okay. S 0 to S some displacement is equals to t0 to t time t. S is equals to ut plus half at square. Okay, that formula contains the displacement from time is equals to 0. Okay, initial position vector was always assumed to be 0 in S is equals to ut plus half at square. Okay, so let's read the next question. Two bodies of mass 1 kg and body B of mass 3 kg are dropped from height 16 and 25 respectively. The ratio of time taken to reach the ground. The ratio of time taken to reach the ground. Okay. Okay. Now there is a thing you need to remember. Whatever be the mass of the body, okay, the acceleration is always same. Acceleration whenever a body is dropped is always g is equals to 9.81 meter per second. irrespective of the mass. Mass can be anything, 10 kg, 20 kg, 1000 kg, 50,000 kg. Irrespective of the mass, whenever you drop a thing, the value of g is always constant, which is equals to 9.81 meter per second. So a ball of mass 1 kg is dropped from this building, okay, or u is equals to 0. The height of this building was 25 meters, okay, and another building of 16 meters, a similar ball was dropped. The initial velocity is equals to 0 and acceleration for both the cases is equals to g. Okay, now the question is asking, find out the time taken to reach the ground, find the ratio of time taken to reach the ground. So we apply a simple formula, s is equals to ut plus half at square. So let's assume s1 to be this case or ball drop for 25 meter building case, and s2 to be the right hand side case or ball drop from 16 meter height. So s1 is equals to 25 meters is equals to ut is nothing but 0 into, so let's case 1b, s1 which is equals to 25 meters is equals to ut, u is nothing but 0, so 0 plus half into a, acceleration due to gravity is always g irrespective of the mass of the body, and g can be taken as 10 meter per second for the simplification of calculation, okay, into t1 square because we don't know the time, okay, or this simplified becomes 25 into 2 by 10 or 5 is equals to t1 square, okay, or t1 is equals to root 5, t1 is equals to root 5. Now for the second case or s2, 16 is equals to 0 plus half into 10 into t2 square, or this becomes 32 divided by 10 or 3.2 t2 square. Now they are asking us the ratio between t1 by t2, okay, they are asking us the ratio between t2 by t1, okay, the time taken by the second case to the first case, or time taken by the 16 meter drop to the 25 meter drop. Therefore t2 by t1 square, t2 square by t1 square, let's write it as t2 square by t1 square is equals to 5 by 3.2 by 3.2, okay, or this can be written as t2 square, sorry, t2 by t1 whole square, t2 by t1 whole square is equals to 5 into 10 or 50 by 32. We eliminated the decimal point, so this can be divided by 2. This is 2 into 25 za and 2 into 16 za, or t2 by t1 is equals to under root of 25 by 16, under root of 25 by 16, or t2 by t1 is equals to 5 5 za 25 into 5 4 za 16, or 5 by 4. So our correct answer is option number D. Correct option is option number D. Sorry, I have written something wrong. T2 was 3.2 by 5. See, T2 was not 5 by 3.2 but 3.2 divided by 5. That means 32 divided by 50. 32 divided by 50, which gets cancelled to be 16 and 2 into 25. So root over 16 by 25. Root over 16 by 25. which is equals to 4 by 5, which is equals to 4 by 5. So our correct option is option number D. Okay, so let's look at the next question. Before starting to look at the next question, just make a note. Well, remember I always told you to, in calculation, always convert everything to the same unit before calculation. So just make a note. If kilometer per hour is given, kilometer per hour is given in the question, that means 1 kilometer is equals to 1000 meters by 1 hour is equals to 3600 second. Okay, this can be simplified as 5 by 18 meter per second. Therefore, whenever the speed is given in kilometer per hour, that means x kilometer per hour or 10 kilometer per hour, x kilometer per hour, to convert it into meter per second, just multiply it by 5 by 18. 5 by 18 x meter per second. Simple unitary method. Similarly, if the speed is given in meter per second, then that is equals to 1 meter per second is equals to 18 by 5 kilometer per hour. Okay, therefore x meter per second or 5 meter per second can be equals to 18 by 5 into x kilometer per hour. Conversion is simply unitary method. Okay, so let's do the next question. A car is moving with a speed of 40 km per hour to be stopped after 2 meters by applying brakes. If the same car is moving with 80 km per hour, what is the minimum stopping distance? That means, let this be a car. Okay, let this be a car. This was moving with 40 km per hour. 40 km per hour. And this one is the velocity. It applies the brake. Brake means the acceleration is in opposite direction. The acceleration is in opposite direction. That means after 40 km per hour, when it applied the brakes and when it applied acceleration in the opposite direction, it took 2 meters to reduce its velocity to 0 km per hour. Within 2 meters, it reduces velocity to 0 meter per hour. Now the question is asking, if the same car is traveling at 80 km per hour, 80 km per hour, okay, what will be the stopping distance if the brake is applied? Brake is applied means the same acceleration will be applied, because braking force is equals to same. The car brakes one change, to apply more force. The braking force will be same. Therefore, the braking acceleration would be same for both. Therefore, under the same acceleration in opposite direction, what is the distance traveled by the car? Okay. Just write down a trick. Braking force is same. Braking force is same. Therefore, negative acceleration or retardation or deceleration, all three can be used in any of the books. Okay, whenever you find the term of negative acceleration or retardation or deceleration, those three mean the same thing. Deceleration, okay, of both condition is same. Both condition is same. Okay, is same. Therefore, for the first car, it stopped after moving 2 meter per second. So let's convert 40 kilometer per hour into meter per second. Okay. So for case A, final velocity is equals to, we are applying v square is equals to u square plus 2as. V square is equals to u square plus 2as. Okay. So v square is nothing but final velocity, which is equals to 0. U is nothing but 40 kilometer per hour. You have to convert that into meter per second. So 40 into 5 by 18 meter per second plus 2as plus 2. The A is in negative direction. A is in negative direction. That means minus A. We considered this direction to be positive, or the right hand direction to be positive. Okay, positive, and the left hand direction to be negative for both cases. Okay, into S. S is given as 2 meters. Okay, or acceleration can be found out by A is equals to 100 by 18 square. If you solve this, acceleration comes out to be 100 by 18 square. Okay, or this is equals to A. Okay, now in the second problem, or B, the same car was moving with 80 meter per second. So if you apply v square is equals to u square plus 2as, v square is equals to u square plus 2as, now the final velocity becomes 0. The initial velocity changes to 80 kilometer per hour into 5 by 18 meter per second. This one I think was 40. Achha, okay. This one is 80. A is nothing but found out to be 100 by 18, or minus 100 by 18 square. Okay, and S was found out to be, we have to find out the value of x, sorry, S. Okay, so let's substitute. 0 is equals to 80 into 5 by 18 square plus, sorry, minus. Why minus? Because this negative sign comes to this minus. Okay, this negative sign multiplies by this positive sign is negative. Minus 2 into 100 by 18 square into S. Upon solving, we get S is equals to 8 meter. When solving this, we get S is equals to 8 meters. So let's solve it. Okay, let's solve it instead of directly writing the answer. So 80 into 5 by 18 goes to the left hand side. So minus 80 into 5 by 18 square is equals to minus 2 into 100 by 18 square S. This minus becomes positive and this minus becomes positive, because negative gets cancelled both sides. Now we can under root or square root both left hand side into and right hand side. So square rooting both left hand side and right hand side, we get 18 into 5 by 18, sorry, 18 into 5 by 18 into under root into 100 by 80 into root s, So let's take this term 100 by 18 and throw it in the left hand side. So 18 into 5 by 18 into 18 by 100 into 18 by 100 is equals to root 2s. So this 18 gets cancelled. 80 5s are 400. Okay, 8 5s are 40. 80 into 5s are 400. Okay, and 400 divided by 100 is 4. So we get 4 is equals to root 2s. Now squaring both sides, we get 16 is equals to 2s, or s is equals to 8 meter per second. So our correct option is option number A. But you have to do this process quicker in examination hall, and this comes by practice. Okay, so let's read the next question. If a car at rest accelerates uniformly to a speed of 144 km per hour in 20 seconds, it covers the distance of. Okay, so simply convert this 144 km into meter per second. 144 km per hour into 5 by 18 is equals to meter per second, which is equals to 40 meter per second, which is equals to 40 meter per second, because 18 8s are 144. Okay, now a car starting from rest, that means initial velocity is equals to 0, accelerates uniformly to a speed of 144 in 20 seconds. Time t is given as 20 seconds. Okay, we simply apply the formula v is equals to u plus at. V is equals to u plus at, or final velocity is given as 40 meter per second or 144 km per hour. Initial velocity is given as 0 because it started from rest, plus a, we don't know a, and time is 20. So acceleration came out to be 2 meter per second square. 2 meter per second square is the acceleration. Now the question is asking, find the distance covered in these 2 seconds. So simply s is equals to ut plus half at square, or distance covered is equals to initial velocity is equals to 0 plus half acceleration we found out to be 2, and t is nothing but 20, or 20 square is equals to 400, or s is equals to 400 meter. Okay, so option number C is correct. Now next question. A ball is thrown vertically upwards with 40 meter per second. The velocity of the ball after 2 seconds will be. The velocity of the ball after 2 seconds will be. So simply assume coordinate system. V is upward with a velocity of 40 meter per second, and acceleration is downward with g, or 10 meter per second square. So now assuming coordinate system, any vector pointing in the upward direction is positive, any vector pointing in the downward direction is negative. Okay, so we simply apply v is equals to u plus at. V is equals to u plus at, or velocity 40 meter per second, sorry, this was the final velocity, not initial. Final velocity we don't know. Initial velocity was 40 meter per second, plus a is nothing but minus of 10 meter per second square, because gravitational is acting in the downward direction, into t is nothing but 2, or our final velocity comes out to be 40 minus 20 is equals to 20 meter per second. Correct option is option number B. Okay. Now this is a conceptual question. 3 different objects of masses m1, m2 and m3 are allowed to fall from rest from at the same point 0 along 3 different frictionless paths. The speed of the 3 objects on reaching the ground will be in the ratio, that means note, make a note, the acceleration due to gravity remains same on all objects irrespective of the mass of the object. The acceleration due to gravity remains same for all bodies irrespective of mass of the bodies. Acceleration due to gravity remains same for all object irrespective of their masses, irrespective of their masses. Okay, so correct option is option number C, 1:1:1. Okay, now let's read the next question. Water drops falls at a regular interval from a tap at t is equals to at height 5 meters above the ground. The third drop is leaving the tap at an instant when the first drop touches the ground. How far above the ground is the second drop at that instant? That means there is a tap. There is a tap. Okay, and there is a ground. The tap is 5 meters above the ground. The tap is 5 meters above the ground. So when the first drop touches the ground, the second drop is just about to leave. Sorry, the third drop is just about to leave. That means the second drop is somewhere around here. Second drop is somewhere around here. Okay. So time taken by the first drop to reach the ground is equals to AC is equals to UT plus half AT square. So therefore time taken by the first drop or this drop to reach the ground by the first drop, by the first drop to reach the ground, is equals to given by S is equals to UT, S is equals to UT plus half AT square, okay, or 5 meters. S is nothing but 5, U is nothing but 0, because the tap is not throwing the water is dropping from the tap. Okay, U is equals to 0 plus half, A is nothing but G. Any vector in the downward direction is positive, any vector in the upward direction is negative. We assumed this to be for the ease of our calculation. Okay, G T square. G is nothing but given as 10. So 10 by 10 or T is equals to 1 second, or T is equals to 1 second. So in 1 second, the first drop reached from here or from the tap to the ground. Okay, therefore the second drop was released. See, within 1 second 2 drops were released. That means within 1 second 2 drops were discharged from the tap. That means for each droplet of water to be discharged, it took half a second. Okay, so therefore the third drop was not released. Okay, I am talking about only release of droplets. So within 1 second 2 droplets were released. Okay, so within 0.5 seconds each droplet was released. Okay, so time taken to release each droplet is 0.5 seconds. So the water drops the droplets after 0.5 second interval. Okay, therefore the second drop was released. The second drop was relieved 0.5 second after the first drop. 0.5 second after the first drop. Okay, now let's do some calculation. Therefore now S is equals to UT plus half AT square. So for second droplets, S is equals to 0 plus half into A is nothing but 10, and the time covered in 0.5 second. The second droplet was released 0.5 second after the first droplet. Okay, and as the third droplet is releasing at 1 second, where was the second droplet? That means the time taken to cover for the second droplet, the time covered by the second droplet is within 0.5 seconds. Okay, the time span of the second droplet is 0.5 seconds. So is equals to 0.5 square, or S is nothing but, we have to find out S. S is equals to half into 10, which is 5. Or let's write down half into 10. 0.5 square becomes 0.25 or 0.25, or is equals to 1 by 4. This comes out to be S is equals to 1.25 meters. 1.25 meters. Okay. So this was a tap. This was the tap. This was the ground. As the first droplet was hitting the ground, the second droplet was 1.25 meter from the tap surface. 1.25 meter from the tap surface. Okay. Therefore, the second droplet was 5 minus 1.25 from this surface, from the first droplet. The distance of the second droplet from the first droplet is given by 5 meters minus 1.25. Therefore, distance from the second droplet from the first droplet is 5 minus 1.25, which is given as 3.75 meters. So let's check the option. Our correct option is option number C. How far above the ground is the second droplets at that instant? That means they are asking the distance from above the ground. They are asking this much distance. They are asking this distance, not the distance from the tap. Okay. So these are the silly mistakes people commit while solving in the examination hall. Okay, don't read the question, what is given, what is asked in the question. Okay. Now let's read the next question. A stone is released with 0 velocity from top of a tower. It reaches the ground in 4 seconds. The height of the tower is. This is a simple question. Okay. A stone is dropped. Drop means initial velocity is equals to 0. Acceleration is equals to 10 meter per second square, which is the value of acceleration due to gravity. Okay. And time it reaches the ground in, time is equals to 4 seconds. So simply apply S is equals to ut plus half at square. Okay. The time taken to drop is equals to height of the tower, or u is nothing but initial velocity, which is equals to 0 plus half into 10 into t square. Time taken is 4 square, or 4 square is nothing but 16, or S is equals to 80 meter. S is equals to 80 meter. Our correct option is option number C. Okay. Now let's read the next question. The body starts from rest. What is the ratio distance? What is the ratio of distance traveled by the body during 4th and 3rd second is? Okay. So during 4th, for competitive advantage, I told you all to remember the formula. Sn is equals to half a 2n minus 1 plus initial velocity. Okay. N is the n second. Okay. So S4. S4 means distance covered by the particle from t is equals to 3 to t is equals to 4. From time is equals to 3 to time is equals to 4. Half a into 2 into 4. N is 4. 2 into 4 is 8. Let's minus 1 plus u. U is nothing but 0. Why? Because the body starts from rest. That means initial velocity is equals to 0. Or S4 is equals to half a into 8 minus 1 is 7, or is equals to 7a by 2. Now S3. S3 is similarly half a. Out here n becomes 3. That means 3 into 2. 2 into 3 minus 1 plus initial velocity is 0. Or S3, which is the distance moved from t is equals to 2 second to t is equals to 1 second, is equals to half a into 6 minus 1 is 5, or is equals to 5 by 2a. Therefore S4 by S3, therefore S4 by S3 becomes, what is S4? 7 by 2a. S4 is nothing but 7 by 2a divided by S3. S3 is nothing but 5 by 2a. And our solution comes to be S4 by S3 is equals to 7 by 5. 7 by 5. The correct option is option number A. Okay. Okay. So let's do a next question. A body is dropped from the top of a tower which falls through 40 meters during the last 2 seconds of its fall. The height of the tower is. The height of the tower is. So let's draw what is asked in the question. A tower or a building is there. From the top of a tower, a ball is dropped, and during the last 2 seconds of its fall, okay, it covered a distance of 40 meters during the last 2 seconds of its fall. The time taken to cover this 40 meters is 2 seconds. Initial velocity is equals to 0 because the body is dropped, and initial acceleration is equals to 10 meter per second square because gravity force is due to acceleration due to gravity. Okay. Now they are asking, find the height of this tower. Find the height of this tower. So we can use this formula. S is equals to ut plus half at square. Okay, where S is the final displacement and 0 is the initial displacement. Ut, in the term ut, t is the final time and t is equals to 0 is the initial time. So we can modify this question. If this is 40 meters, if this is 40 meters, then this much distance is h minus 40. If this is 40 meters and the full length is 8 meters, this much distance is h minus 40, and the time taken from the top of the roof to fall this much distance, is something called, okay, let's say time taken to cover the whole distance is equals to t. Time taken to cover the whole distance is equals to t. Therefore time taken to cover this much distance is equals to t minus 2 seconds. Okay, t minus 2 seconds. Time taken to cover from top of the roof to h minus 40 distance. So let's apply this formula. S is equals to ut plus half at square. So let's cover the formula for full distance, or S is equals to h, the time taken to drop the full length of the building. The displacement is h. Ut, initial velocity, is equals to 0. So plus half. A is nothing but 10. T square, or capital T square. This gives us h is equals to 5t square. 5t square. Now let's take the equation again, but this time we'll use the equation to measure this much distance only. That means h minus 40 distance. So therefore h minus 40 is equals to displacement is equals to ut. Ut is nothing but 0 because initial velocity is 0, plus half 10. The time taken is t minus 2 second. T minus 2 second whole square. Understood? This was nothing but S is equals to ut. Ut becomes 0 because u is equals to 0. Half at square. Half at square. Okay. So let's simplify this. When you simplify this, this becomes h minus 40. H minus 40 is equals to 5 into t minus 2 whole square. 5 into t minus 2 whole square. Now from equation A, from this equation A, we see that h is equals to 5t square, and from equation B we can see that h minus 40 is equals to 5 into t minus 2 whole square. So can we substitute this 5 minus t square out here in this h? Can we substitute this 5t square out here? Okay, so if we do that, our equation becomes 5t square minus 40 is equals to 5 into t minus 2 whole square. Okay, if we substitute this 5t square in this h, okay, our equation becomes 5t square minus 40 is equals to 5 into t minus 2 whole square. So let's write this properly. Okay, h minus 40 or h minus 40, which becomes 5t square minus 40, 5 capital T, no, 5t square minus 40 is equals to 5 into t minus 2 whole square. 5 into t minus 2 whole square. So we expand it. 5t square minus 40 is equals to 5 into a minus b whole square is equals to a square plus b square. B square is 2 square minus 2ab, 2 into t, or minus 4t. Okay, or let's solve this equation quickly. Okay, 5t square minus 40 is equals to 5t square plus 20 minus 20t. 5t square and 5t square gets cut. Okay, or 20 is equals to 20t, we take in the left hand side and we bring the minus 40 to the right hand side, is equals to 60, or t is equals to 3 seconds. That means t is equals to 3 seconds, which means the time taken to cover the whole building or time taken to fall through the whole building is equals to 3 seconds. Time taken to fall through the whole building is equals to 3 seconds. Therefore, height of the tower is, we simply apply s is equals to ut plus half at square, or h, where height for the whole building, ut is nothing but 0 because initial velocity is 0, plus half into 10 into time taken to cover the whole building is 3 seconds, or 3 square, or h is equals to 5 into 9. 5 into 9 is equals to 45 meters. Okay, so our correct option is option number D. Our correct option is option number B. Now let's look at the next question. What will be the ratio of distance moved by a freely falling body from rest in the 4th and 5th seconds of journey? So I told you all to remember a formula. Sn is equals to half a 2n minus 1 plus u. Okay, from rest in 4th second means t is equals to 3 to t is equals to 4, and 5th second means t is equals to 4 to t is equals to 5. Okay, so if you simply apply the formula, s4 is equals to half into acceleration is nothing but 10. For 4th second, 2 into 4 minus 1 plus initial velocity is 0 because the body was falling from rest, plus 0, or s4 is equals to nothing but 35. Now let's calculate for s5. S5 half into 10 into 2n, which is 5 into 2, or 2 into 5, same thing. 2 into 5 minus 1 plus 0, or S5 is equals to 45. Now they are asking find the ratio of S4 to S5. Therefore S4 by S5 is equals to 35 by 45, or 5 7s are 35, 5 9s are 45, or S4 by S5 is equals to 7 by 9. Our correct option is option number B. Okay. Now let's read the next question. A car is moving along a straight road with uniform acceleration. It passes through point P and Q separated by a distance with velocity 30 km per hour and 40 km per hour. The velocity of the car at midway between P and Q is, okay, so there is a point P and point Q, point P and point Q. So midway between these 2 points there is some point, okay, and the car passes through this point at 30 km per hour and through this point at 40 km per hour. This was our question, okay, this was our question, and the acceleration was constant, but we don't know the value of acceleration. We don't know the value of acceleration. The question is find out the velocity of the car when the car is at the midpoint. The car is at the midpoint. So let us assume this entire distance to be x. Let us assume this entire distance to be x. So we can apply the formula. A is equals to v square is equals to u square plus 2ax. Okay. Final velocity is nothing but 40 square. Initial velocity is nothing but 30 square plus 2a into x. Okay. 40 square is nothing but 1600 minus 30 square is 900 is equals to 2ax, or 1600 minus 900 is equals to 700, and 700 divided by 2 is 350 is equals to ax. So let this be our equation A. Let this be our equation A. Now from equation B, again we apply the formula v square is equals to u square plus 2as. Okay, but out here the initial velocity is 30 km per hour, but the final velocity we have to find out at the midpoint. That means at the midpoint, that means x by 2. Out here s becomes x by 2. So our final velocity becomes velocity at midpoint. Okay, our final velocity becomes velocity at midpoint. Or v square is equals to 30 square plus 2ax by 2. Okay, or v square is equals to 30 square plus ax. Now from the previous question we already found out the value of ax. Ax is nothing but 350. So or v square is equals to 30 square is 900 plus ax is nothing but 350, or v square is equals to 900 plus 350 is 900 is equals to root over 1250. Okay, this can be written as 625 into 2 or 25 into 25 into 2. Okay, or our final velocity is, sorry, you all understood now. I'm just going, v square is equals to 1250. Okay, or v is equals to root 1250. Root 1250 is nothing but 625 into 2. Okay, and 625 is 25 into 25. So the square root becomes 25 into root 2. Our correct option is answer number C. Okay. Now this is, we'll proceed to the next thing. Okay.